Start your sir. Yeah, hello friends, good morning. Welcome to this demo session on DevOps and AWS. My name is Prasanth. I will be your instructor for this demo session and for the course of DevOps and AWS. Friends, first things first, am I audible? Is my voice clear? Can somebody please confirm me?
Yeah, yes.
Yes.
Thank you, friends. Thank you for the confirmation. Yeah. So let's get started with our discussion. Prior getting into the class, I would like to give a quick introduction about me. Yeah, my name is Prasanth. I got around 12 plus years of experience in the field of IT. Back in 2010, I started my career as a systems administrator at Broadridge Financial Services. I worked for a few organizations like Deloitte, United Health Group as a systems administrator, and into some different roles like a system developer to SharePoint developer. So a lot of transitions happened, and in 2013, I got an opportunity to work for an on-site client in Dubai for an online trading portal called Dubai Trade, a government agency. There, I got exposure to the field of cloud and into DevOps. I got pretty much exposure over there. For the past 7 years, I was working in this field, and for the past 2 years, I've been training people on DevOps and AWS. Okay, that's all about me. That's quick introduction about me, and I would like to know a few things about you too. Okay. Few things about participants today who have joined the session. Just few introduction. Few things about you, like from which background are you currently working? If so, you are from IT or non-IT. Just few details, friends. Let's start with Nageshwar.
Yeah, hi Prashant, this is Nageshwar.
Hi Nageshwar.
Yeah, I'm having 9 years of IT experience. Currently, I'm working as a user middleware engineer.
Oh, very good. Yeah.
So I'm trying to move into DevOps engineers.
Okay, cool, Nageshwar. 11 years of vast experience.
9 years.
Here at Nageshwar.
9 years.
Yeah. Okay. Next, Sai Anvesh.
Hi, Prashant. So, myself, I'm working as an IT tech support engineer since last 5 years.
Oh, yeah.
Recently, I had switched to DevOps as a DevOps engineer. Still, like this is like an internal transaction.
Oh, okay.
So,
yeah.
Still, they are ready to give me training, but it will take much time. But I'm here to gain some more knowledge before they give me training.
Prior to that, you want to get updated with
yes, I need
yourself. Yeah. Excellent. I appreciate that. Yeah. Next, Pratyusha ji, you can introduce yourself to us.
Hi Prashant, I'm Pratyusha.
Yeah, hi.
I am having 4.5 years of experience into IT technical support and Active Directory administration.
Oh,
currently, I'm working for entertainment partners.
Okay, cool, Pratyusha ji. I appreciate it. Yeah. And Sai Teja.
So,
Sai Tejas, Sridhar, Syed.
Hi Prashant. I'm Sridhar Pedavalli. I'm from Vijayawada.
Yeah,
I
hi,
don't have
Sridhar.
any IT experience,
Mhm.
but I want to start my career in DevOps platform.
Okay, Sridhar. Yeah.
So I finished my graduation in 2017.
Okay.
So I worked in some other field.
Mhm. So you want to get into the field of IT?
Yeah.
So
So I choose this platform.
okay, perfect. Yeah.
Thank you.
And Sayed?
Hi, Prashant.
Yeah,
Hi,
hi.
Prashant. This is Sayed. Actually, I'm having 4.5 years of experience. Currently, I'm working as a big data developer.
Oh, okay, cool. So we got a big data developer in our session today. Very good. Yeah, next we are left with Krishnakant, right? Hi, Krishnakant. Okay, it seems Krishnakant is away. Fine, friends, fine. Just to know, to know about the participants' mindset, and then to carry out, go forward with the discussion. That is the idea. I asked it for your work experiences, and yeah, pretty good amount of people have IT experience already. You're working in the field of IT. I appreciate all of you. And now a question. Before getting into our discussion, I would like to begin our discussion with a question. Why DevOps? Why DevOps? Why you have chosen DevOps as the platform to shift your career into IT, or to get better in the field of IT? Definitely, I know it's a stupid question because nowadays all of us know that there's a huge demand to DevOps engineers and a huge demand to the cloud technologies. So that would be your answer, definitely, for sure. So yeah, friends. So that is that is what we will discuss today. But before getting into whatever the platform we have chosen for our careers, to migrate into a separate field, I do appreciate that, but prior, making your decision, are we clear with this? Are we clear with choosing the correct platform or not? Let's discuss that in our session today, and let's try to understand what exactly is DevOps. Is it a technology, or it's a set of principles and practices? Where DevOps actually fits in the field of software? Let's try to understand. Let's try to get answers to all these questions in our session today. Okay, so. Before we getting into the session, just give me a minute, friends. I'll start recording this session. Oh, it's getting recorded. Fine. Just in case if anyone wants to get this recorded session, you can reach back to us. You can provide your mail IDs so that I'll share the recorded session with you after done with our session. Okay. Yeah. So now, what is DevOps? This is the definition. DevOps is a set of practices that combines software development and IT operations. It aims to shorten the systems development lifecycle and blah, blah, blah. This is actually the definition, which would definitely doesn't make any sense to us when we read it for the first time. So if we understand the process where DevOps actually fits in, then after understanding that, when we get to this definition back again, then definitely it would make a lot of sense to us. Okay, so the agenda for today is we're going to cover all these concepts. What is software development, different phases of software development, okay, agile methods, Scrum team, and let's address all these, and then get into what exactly we are going to learn, what is the outcome if we get with this DevOps course. Right? So DevOps, it's mostly DevOps is a set of principles and practices which are implemented in software development to software delivery. In the process of software development to software delivery, we implement DevOps principles. So first things first, we have to understand what is software development and how software development happens at organizational level. Software organizations, how do they handle projects, and how they how they do things like let's say if a software development company agrees to deliver a product to a client, deliver an application software to a client, what sort of stages are involved in their in the organization at the organization level? Let's try to find out. Since we have a couple of participants who are from non-IT background, I will take you with I'll walk you through some basic examples only for today. Okay, not going much deeper into the way too technical terms. Yeah, let's take the simple example. If we go to a bank like HDFC Bank or ICICI, and if we do a transaction, like I want to deposit some amount into my account, when we go deposit amount, the transaction is processed on an application software which is related to that HDFC Bank or that particular bank like ICICI whatsoever. If we go to post office and we want to send a parcel to some other state, post office, they have their own particular software, and through that software they register our package, and things do happen. They give us a track, a shipment number which we can track our order, how things are happening. If we go with an e-commerce site, we do transactions online, and there is a particular software for every domain, every field, and through those those application softwares, we are performing transactions, or we are able to interact with those businesses, right? But the question here is banking. It's a different domain. Post office, it's a different domain, right? And hospitals, they are of different domain. Who are developing application softwares for these different domains? The businesses themselves, they are developing application softwares for them, or they are relying on some other organizations for to get an application software for their transactions? Means definitely the answer is some other organizations, they develop application softwares for them to carry out their business activities. Why? Because software development itself is a vast subject and a major task. If let's say HDFC Bank, they develop their application software on their own, when they are going to focus on their business, when they are going to compete with their competitors like other banks, if their focus is completely into developing an application software for themselves, they don't go forward in their business. So what happens is in software, what happens means different domains, if they want some application softwares, they rely on some software development organizations. Now let's take an example. In this example, let's say there is a banking firm called Sinotech Banking LLC. They want to start their operations in India, and they want an application software for carrying out their day-to-day business activities. And in their research, they found a software company named Trident Software Solutions, which is a noteworthy software development company who is developing application softwares for different clients, clients of different domains. And they have very good expertise into developing application softwares for particularly for finance domains, finance domain. So this banking firm, they reach to the software solutions company, asking them to develop an application software for their business activities. Now at the software organization level, let's say a deal has been made between this banking firm and this software development company. What happens means this is a traditional approach of software development process, which begins at the software development organization level. They got a client, they have to develop an application software for the client. Now what happens at the organization level, software organization level, means typical software development process begins with this first phase called requirements gathering. This the software organization, they collect all the requirements from the client. What sort of application are you expecting? What sort of features are you expecting in your application? Okay, all the requirements are collected. Maybe the client might say, I need customer account creation feature, deposits feature, withdrawals, loans, net banking, phone banking. All these features should be included in our application, right? So all the requirements are collected. Once the requirements are collected, okay, let's say these are all the requirements provided by the client. Once the requirements are collected, the project moves into another phase, which is analysis phase. In the analysis phase, what happens is the software development organization, they take all these requirements into consideration, and they try to find on which platform to develop the application, whether on .NET or Java or some other advanced technology. Taking all the requirements into consideration, they make a decision. And they have to take a lot more things into consideration, like since it's an application which is for a financial institution, the application should be very secure. Performance of the application should be optimal because banking sector, they do transactions on a regular basis, on a daily basis. So the application performance should be optimal. So which platform is going to provide or satisfy all these conditions, they finalize that platform. And that is what happens in the analysis phase. And next, the project moves to design phase, where an entire blueprint of the project is designed with entity relationship diagrams, data flow diagrams. The entire outline of a project is made at this design phase. These are the requirements of the client. Now, where to start? Now, let's say I got a project and I have to develop an application software for the client. Should I start with phone banking feature because the client has this requirement? Or should I start with the deposits feature? Or should I start with identifying the dependencies? Customer account creation feature is the dependency to withdrawals or deposits or whatsoever. Without developing this feature, how can I get started with email statements or phone banking? Right? So in the design phase, the entire blueprint is made. If the application has to interact with the backend databases, all that is made, all the structure is developed here. A draft, it's something similar to, let's say, I got a plot and I want to construct a house there in that plot. What I do first, I will reach to an architect. I'll explain all my details, all my requirements to the architect. I'll speak out my my design, the design in my mind. And what happens? The architect provides me with a blueprint. That blueprint I'll give to my construction team, and the construction team, according to that blueprint, they start developing or constructing my house. Similarly, in the design phase, whatever the blueprint is finalized by taking all the requirements into dependencies into consideration, what happens? The project then moves into coding phase, where a team of developers start developing the application. They take all these requirements into consideration, follow the design strategies, and develop the entire application. The application here we are talking about is a monolith application, meaning an application which is developed with all these features and delivered to the client as a wholesome, as a complete application. An application with all these features developed and delivered to the client. So definitely, to develop an entire application with all these features, it would take time. So the development team, they start coding the application. Okay, they start developing the application, and it takes some time, considerable amount of time to develop the entire application. Once done, the project moves into testing phase. Once an application is developed, it is not released to the client directly. We know that some sort of tests are performed on that application. How is the performance of the application, right? And multiple developers develop the application, right? So whether the features developed by developer A are integrated with the features developed by developer B or C. So some sort of tests are performed, like integration testing, just now we discussed it. Whether the code written by developer A is integrated with the developer B or not. These kind of tests. Performance testing, like if the application should interact with a backend database, whether the application is, whether the queries are getting pulled on time or not, all the SLAs are satisfied or not. These are all tested by a QA team. And once let's say UAT is done, meaning user acceptance testing is done, there are wide variety of tests that happen on a software application. And once UAT is done, ensuring UAT is done, what happens? The application is delivered to the client. This is called as implementation phase. Deploy the application to the client environment to Sinopec Banking LLC. Once the application is deployed to the client, finally, the final stage is maintenance. As a software organization, since we develop an application software to the client, we have to ensure to provide maintenance to the client, ensuring that the application is working absolutely fine. Okay. And if there are some updates to be performed on the application, we have to perform those. If the client experiences any issues with the application, we have to address them. Training the team at the client level how to utilize the application. Okay, these are all provided by the software organization in this maintenance phase. We are just discussing about the outline here, friends, what happens in each phase. But there are a lot more steps involved in each and every phase. And if we try to discuss them, that becomes an academic subject, okay, which might last for 6 months. So I'm not going to do that. So this is a typical or a traditional approach of software development. What are the phases involved in software, software development process? These are all the stages which happen at software organization level. Now, once all these phases are done, that is it. The project is done, and the software organization switches to another project, and they keep going with their with their works. Now, software development in this process, in this traditional approach, it was successful back in the past. Okay, it is a successful model, and this this software development model is also known with another name, which is a waterfall model. If you see the structure, it is something similar to a waterfall, right? So this software model is known as a waterfall model. But in the current day scenario, this software development process is not feasible or not suitable at all. Why? Why means there are a lot of downsides to waterfall model. Let's try to understand that. These are some of the major downsides to a waterfall model, like requirements change, lack of involvement of customer or business, accuracy of estimations, schedule and cost overruns, and not much time left for testing or fix the defects. What are these downsides? Let's try to understand. Initially, we got these requirements from the client, but later point of time, client said there are some more requirements, and those should be fulfilled, and even those have to get included in the project. Once the project is in requirements phase itself, not a problem. We collect those new requirements to include them and go ahead with, no problem. But once the project moved to analysis phase, now let's say client came up with some more new requirements. Even here, there is no much damage happens. We collect those new requirements, again do a new analysis by taking the new requirements into consideration. Let's say the project moved to design phase, and here client came up with some more requirements. Not a problem. We can accept them, and again, consider the new requirements, do analysis again, and try to implement design strategies by taking new requirements into consideration. But what if the project moved to coding phase, and now client came up with some requirements, new requirements? What happens is, in waterfall model, we don't entertain any requirement changes once the project moved to coding phase. Coding phase is the phase where developers are getting into action and they are developing an application. Just imagine, I brought a blueprint to construct a house in my plot. The blueprint is for a duplex house. And my construction team, they started constructing the house. At some point of time during this construction process, what I did is I brought another draft or another blueprint, which is for an apartment. And I insist my my construction team saying, construct a house according to this new plan, not with the previous one. Imagine how difficult it would be for the construction team to change or to reconstruct, according to my new design. Unnecessary, waste of time. Sorry, it involves a lot of struggle. Whatever they constructed so far, they have to collapse everything, and again they have to reconstruct according to the new design, which involves a lot of factors. Like I have to spend a lot more money. Okay, and the project gets extended. If I made a deal, they will provide me a house by with a tenure of 6 months. Within a matter of 6 months, they have to provide me a house. Now, half of the construction happened, and again they are collapsing everything, and they have to start from scratch. Definitely, the project deadline gets extended, right? So these are some of the challenges which are involved in software development process with waterfall model. If requirements are, if there is a change in requirements, they are entertained only till some particular point. Requirements gathering, analysis, design phase, that is it. After design, if there are changes in requirements, no, we don't entertain them. Lack of involvement of customer or business. Since it's a monolith application, the application has to be developed, entire application should get developed. Till that point, client should wait, right? So it might take 6 months of time, or 7 months, or 1 year, or 2 years, we don't know. Till that point, client should wait to get his application software back. So client is not very much involved. He don't know what exactly is happening with his application. He gets to interact with this application at this level, at UAT, right? Till that point, client gets some updates from the software organization saying project is in analysis phase, project is in design phase, project is in coding phase. For level 1 coding completed, level 2 coding completed, project is in testing phase. This way, client gets some updates from the software organization, software firm. So lack of involvement, client doesn't know what exactly is happening with his application at this point in this waterfall model. Accuracy of estimations. The client might be expecting that, the application, since I handed the project to a trustworthy company, definitely my application is going to perform robust. But at the, the estimations might go wrong. We cannot guarantee that we are going to provide a robust application to the client. Client's expectations might be different, and the outcome might be different, right? Schedule and cost overruns. Waterfall model doesn't guarantee you that, everything, whatever planned, those happen according to the time. Or, this is one of the major drawbacks of waterfall model, schedule and cost overruns. Schedules keep on kicking in and extended. So once schedules are extended, definitely the client gets affected. He have to pay a lot more expenditure for for those over for the extended schedules. And one major drawback in waterfall model is not much time left for fixing or testing or fix the defects. Let's say the project deadline is 6 months. Development team developed the entire application. It took 4 months for them to develop the application. Project deadline is 6 months. By the end of 6 months, we have to deliver product to the client. Now, how much time is left for testing team to test the application? 1.5 months, because we don't say 2 months, because the later 15 days, we have to deliver product to the client and update the client, train the client how to utilize the application. So production for deploying the application to production, let's consider 15 days. So only 1.5 months is left for testing team to test the application. And during this process of testing, let's say QA team, they identified some issues. They have to route back to the development team saying, these are some of the issues identified in the application, fix them. And development team, again, they have to rework on that code, on their code. And again, report back to the test team saying, yes, whatever the concerns are raised, we addressed them, have a look. And again, test team, they test the application. And this process keeps continuing until the point test team, confirms or test team are satisfied with the product. It keeps on going. So not much time left for testing team to test or fix the defects. Okay, so this is one of the major drawback with waterfall model. So friends, that is why in the current day scenario, as we know, softwares, they're getting developed at a rapid phase, right? Every day there's a new piece of software getting into the market, and we are all businesses, they are competing with one another. So software development should be made robust, secure, and super fast, right? So with this waterfall model, clients are not happy because they are getting product very so late, and whatever the investments they are doing, they are not getting something in return in a very short time frame. So to address these issues, there came a lot of other models into existence, like iterative model, spiral model, incremental model, V model. All these different models came as advancement to waterfall model, but none of them became so successful as this model called agile. So what is agile? What's so special in agile model? When this agile model came into existence, software organizations, they embraced this agile model, and they changed the software development, meaning the implementation of software development with this agile model. What's so special? Why agile model became so successful? Let's try to understand. In agile model, software development happens in incremental fashion, meaning not as a monolith application. We develop application in the format of increments, meaning instead of developing the entire application at a time and releasing to the client, what we try to do, we try to find the priorities. We try to address the priorities of the client in first place. We communicate with the client, ask them, what sort of application are you expecting in the first place? And let's say client said, I need an application with these features: customer account creation, deposits, and fixed deposits. If you provide me with an application with these 3 minimal features, initially, I can commence my business. I can welcome my customers saying, you can open a bank account with us, you can deposit in our bank. Withdrawals, maybe after 2 months, it is possible to withdraw amount from our accounts. Let's say client can commence his business this way. So what happens here? Software development happens in agile model in incremental fashion. This agile framework addresses all the downsides, whatever we discussed so far in Waterfall. In agile model, all these downsides are addressed. Like, what if the requirements change? Not a problem. Agile understands all the requirements cannot be collected in the beginning of the project, and all the requirements, requirements we can collect at any phase throughout this agile process. Requirements can be collected or changed throughout the development life cycle. Tests early and often. This is one of the major drawbacks, right? But here, agile addressing that too. Tests do happen early and often, and ensuring higher quality. Software releases, we ensure that they are of higher quality and we release them to the client. Reduced risk and earlier software releases. Since application development is happening here in incremental fashion, what happens? Releases do happen at a rapid phase. We don't release the entire application at a time, rather we release in the process of increments. Okay, so in agile model, let's say these are the requirements of the client. With Scrum framework added to agile, what we try to do is we try to break the entire application into smaller chunks or smaller modules. Okay, and we fix a time frame to each and every module. Okay, let's say the time duration varies from 2 weeks to 4 weeks, which is typically known with other names sprint. Okay, in Scrum framework, we have a Scrum team comprised of developers, a Scrum master, a product owner, testers, and and system engineers. These are all the teams involved in a Scrum framework. All these teams work together. They identify this is the product which we have to develop to the client. These are all the requirements of the client. Now, how do we develop? How often we can release the product or release an increment to the client? They decide, they discuss all of these concepts together, and they try to break the application into some modules. A development team is involved here. Development team, they say, to develop an application with these 3 features, for us, 2 weeks of time is sufficient. Now, a Scrum Master fixes a fixed time duration, which is called as a sprint, and he assigns some tasks for every sprint, some features to be developed for every sprint. And in this sprint duration, what happens is, in this sprint time duration, they go with this approach: plan, code, test, and review. Plan, code, test, and review. Meaning, let's say in sprint 1, they have to develop only 3 features. Scrum Master checks with the client. What are your priorities? Let's say client gave us these priorities. Client is expecting an application with these 3 features, like a customer account creation. Next step, customer account creation feature, deposits, and fixed deposits. Provide me with an application with these 3 features in the first place, so that I start my business. That is what we got an update from the client. Now, these features are added in sprint 1. These features are added in sprint 1, and your Scrum Master fixes a time duration by checking with the development team. How much time it will take for you to develop these 3 features? Development team, let's say they said, it takes 2 weeks of time for us to develop an application with all these 3 features. Now, they plan accordingly, code the application, and here, test team and coding, both of them happen simultaneously. Okay, developers write code and tests happen on that code simultaneously. It's not like developers write the entire code and then tests happen. No, with the automation, with the advent of automation, test team, what they do, they write some test cases, and those test cases are automated on the code whatever developers are developing, and this process keeps on happening continuously. And by the end of 2 weeks, ensuring this product is developed, tested, and it is released to the client. Ensuring the product is developed with all these features, the product is tested, and ensuring everything is fine, the product is delivered to the client. This is how in agile model software development happens in incremental fashion. For every sprint, some features are added. Let's say just in case one of the features in sprint 1 is not completed, in the provided time frame. Let's say fixed deposits feature is not completed. Now what happens? This fixed deposits feature is treated as a backlog. Okay, this feature is not completed by the development team, and QA team are unable to fulfill this. Now an application with only these two features is added to the client, and this fixed deposits feature is added as a backlog to the followed sprint, the second sprint. In the second sprint, developers have to develop a feature called loans, but the priority goes to whatever the backlog is, whatever is left as a backlog, that feature is added as a priority to sprint 2, along with the added feature, which is loans. So by the end of sprint 2, developers should develop an application with these two features, fixed deposits and loans. And the end of sprint 2, what happens? This an application with these two features is added to the client. So client gets to interact with his application within a very short time frame. With this agile model, client gets his application within a very short time. And for every sprint, the application grows dynamically at the client level. Sprint 1, an application with these three features are added. Sprint 2, by the end of sprint 2, at the client level, client has an application with account creation feature, deposits, fixed deposits, and loans. By the end of sprint 3, client has an application with account creation feature, deposits, fixed deposits, net banking, phone banking. This way, for every sprint, we deliver an increment to the client. Okay, so this process of software development, microservices, we don't go with developing an application as a monolith application here. We develop application in the format of increments and deliver to the client there. And client gets to interact with this application within a very short time frame. So what is the advantage with this agile model? It's ROI, meaning returns on investments. Client is investing a lot of money into this software organization, and they get something in return within a very short time frame. And one more advantage here, let's say for some reason the sprint 1 went entirely wrong. Client is not at all happy with sprint 1. So what happens? There is a possibility that software development organizations, they can rework on sprint 1, fix all the issues, and take those things into consideration and go and correct the later sprints accordingly. If not, what happens? The entire project travels in a wrong manner. Let's say sprint 1, some of the dependencies are not coded correctly, or the features are not developed properly. For sprint 2, there are some dependencies, features to be inherited from sprint 1. So sprint 1 is wrong. So then inherited properties, we will correct them by reworking on sprint 1 so that sprint 2 won't go wrong. So this is one of the major advantages too, right? And tests are happening often. Tests are happening, rapidly. Coding and testing happening simultaneously. So we are ensuring that the product, whatever we are releasing to the client, it is a product ensuring with quality we are releasing it to the client. In agile model, friends, in agile model, releases are our priority. Remember this. Releases are our priority, ensuring quality. Releases are the priorities here, and ensuring quality software releases should happen. And one more thing, how a typical structure of software development happens in agile model, let's try to understand. Let's say this is the software project assigned to us, and we have broken that project into multiple modules called as sprints. Now we have to work on sprint 1. Let's say this is sprint 1. The black box is sprint 1. Some developers gets deployed working on sprint 1. Okay, and let's say 3 developers got deployed, and they have to work on sprint 1. Now these developers, they are working in isolation, and 3 of these developers, in sprint 1, 3 features to be developed. Developer A picked feature 1, developer B picked feature 2, and developer C picked feature 3 in the sprint 1. These guys, they develop in isolation, they work in isolation, and all the code, whatever the developers are writing for sprint 1, that code is uploaded into a version controlling tool called GitHub. Maybe GitHub or SVN. To a version controlling system or to a version controlling tool, the code is uploaded, all the code written by these 3 developers. An isolated code, is uploaded here, but the code is integrated together as a single unit at this version controlling system. All the code written by developer A, B, and C is brought together as a single project or a single increment. Now, the code uploaded to version controlling tool is downloaded by, there's a team called build and release engineers. These build and release engineers, what they do, they download the raw code written by developers onto their machines, and they convert the code into an application. They bring that code as an application. Okay, so let's say developers have written some Java code and uploaded some raw code into version controlling tool. That code has to be converted as an application, and that task is done by a team called build and release engineers. They convert the code into an application format using some build tools. Like if it is a Java project, build and release engineers use a tool called Maven. If it is developed on .NET, they go with a tool called MS Build. Okay, so based on different technologies, they work on and they convert the code into an application format. Now, this code is, once the application is developed, that application is deployed into QA for test purpose. The application is deployed into QA for test purpose. And QA team, what they do, they perform all sort of tests on this application. And if they find any issues, QA team, if they find any issues, what happens? They revert back to the development team. They reach out back to the development team saying, there are some issues found within the application, fix them. And developers, what they do, they look into the, concerns raised by the QA team, and they try to rework on their code and upload their code back into version controlling tool. And again, they rework on their code and upload into version controlling tool. Again, the code is pulled by this build and release engineers, and an artifact is generated. That artifact is deployed into QA. QA tests the application. And this process keeps on going. This process keeps continuously happening till the point QA finalizes the product, till the point QA identifies the product is free from all sort of issues. Okay, and finally, let's say if QA finalizes the product, then what happens? The product is delivered to the client. I'm keeping things at minimal here, friends, not discussing all the stages involved in this process. I'm keeping things at very minimal and trying to make things simple for us. But there are some more stages involved, like pre-production stage, UAT, where UAT happens. There is one more stage involved, but I'm just trying to keep things simple. So this is a typical structure of software, how software development happens. Developers upload code into version controlling tool, and that code is also validated. We have a tool called SonarQube, using which we validate the code, whether the code written by developer that is according to the coding standards or not, whether developers are following the coding constructs which are imposed by the coding consortium, whether they are fulfilling them or not. That is again, if we put all of them together, what happens? The discussion gets extended. So I'm just simplifying things here. So the code, whatever is uploaded here, let's say it is a valid code. That code is downloaded by build and release engineers. They convert the code to an artifact. An artifact gets deployed into QA environment. QA team tests the application. If there is a problem, they reach back to the development team. Development team, again, they rework on their code and upload to this version controlling tool. Again, that code, updated code is downloaded. Again, an artifact is created. And again, a deployment happens into QA. This keeps on happening till the point QA finalizes the product. Once it is finalized, then the product is released to the client at production level. Okay, so this process keeps on going for every sprint. Once sprint 1 is done, then what happens? Developers gets deployed on sprint 2. Once sprint 2 is done, they work on sprint 3, sprint 4, sprint 5. This way, software development happens in incremental fashion. Now, let's say at production level, sprint 1 is completed. A product is an increment is added here. Sprint 2 is completed. Then what happens? One more increment gets added here. Okay, sprint 3 is done. One more increment gets added. So this way, the product at the client level, or the product, what happens for every sprint, it grows dynamically. Some more features get added. for every sprint. This way we deliver product to the client, right? It's not like a monolith application. The entire application is not delivered at a time. So with this approach, the advantage here is requirements can be collected throughout the development lifecycle. If there are new requirements to the client, we inherit them and we add them in another sprint. Tests are happening early and often. In this process of software development at this QA level, tests are happening rapidly. So we can automate this entire process and speed up this process. So definitely agile model, we are trying to fulfill the motive of agile, which is releases should happen at a rapid pace, ensuring quality. And since all these conditions are getting satisfied with agile, that is the reason agile methodology became very successful and companies started adapting to that. But there is a challenge in agile model too. If we are developing application softwares with agile model, even in agile there is a challenge. What is the challenge? Let's try to understand. In agile model, we structured this way. There are multiple teams involved. Like over here, there is a team called system engineers. System engineers. What is the responsibility of these system engineers? Let's try to understand that. Now, let's say, friends, developers developed an application, an increment. They have written code for an increment, uploaded the code to version controlling tool. Now the code is downloaded and an artifact is generated by build and release engineers. Now this artifact, in order to execute this artifact or in order to run this artifact, some dependency softwares are required. Like if we try to install Skype, sometimes we get a message saying .NET framework so-and-so is required to meet the standards to install this requirement. Similarly, let's say this artifact requires some dependency softwares. Like let's say it's a Java application, and where we want to deploy this application on that platform, there should be some particular version of Java required to run this application. Let's say Java version 8 is required. Java version 8 is required to deploy this application and to get the most out to run this application. Now, this platform where build and release engineers plan to deploy this artifact, that platform should get updated with this requirement. The platform should get configured with the requirement which this artifact is expecting. Who does that task? Means build and release engineers. They reach out to system engineers, and system engineers' responsibility is to configure the platform according to this artifact. Okay, and it is the responsibility of system engineers to configure the production environment too. Okay, if we have to release the artifact to production, system engineers should make the platforms ready according to the requirements of this artifact. Build and release engineers, without the platform being ready, they cannot deploy the artifact into QA. So friends, here is a challenge, and there is one more team involved. These guys, their responsibility is to make the platform ready. And now, to make the platform ready, to make this these platforms ready, system engineers gets involved. Now let's say if there is a proper coordination between these teams, since there are multiple teams, if there is a proper coordination between all these teams, things will happen so fast and things will happen smoothly. We ensure releases happen at a rapid pace on time. But let's say if there is no proper coordination, like a development team, they have written some code, uploaded the code into GitHub or version controlling tool, but they did not update this build and release engineers. Build and release engineers are unaware of there is some code residing in the version controlling tool. Since they don't know, they don't download the code and create an artifact. Let's say the next day, build and release engineers, they themselves identified there's a code residing in GitHub, and they downloaded the code and created an artifact. This artifact requires a dependency software Java 8, but build and release engineers did not update the system engineers to configure these platforms, or at least QA platform. QA team, system engineers, finally, they got to understand QA platform should get configured with Java version 8. And they did configure, but they did not update build and release engineers. Now, build and release engineers left for the day, and day 3rd, they identified that QA platform is configured with the required dependency software. And now they deployed the artifact to QA environment, and build and release engineers are not communicating with QA teams saying there is an artifact to be tested. QA team, they identified themselves that there is an artifact to be tested, and they tested the application. They found some issues, and they routed back to the development team saying, fix the issues. Development team, they reworked on the code, which is whatever the concerns are raised by QA, and they uploaded their code again into version controlling tool. Now, build and release engineers are unaware of it. Again, they realized that there is some more advanced there is a revised code present in the version controlling tool. We have to download it. They realized it after 2 days or 3 days, let's say. They downloaded the code, created an artifact, and deployed to QA. So if there is no proper coordination, friends, what happens? Things get delayed. If things are getting delayed, what happens? The motive of Agile, ensuring quality releases should happen, and the releases gets delayed. If a release is getting delayed, sprints gets delayed. If the sprint is delayed, that impacts the entire software process. The later sprints gets impacted. So to avoid this, what we do is we try to ensure, we ensure to automate this entire process. Now, since agile model, we are facing some issues. What we try to do is we address them by implementing DevOps methods here. We address all these issues by implementing DevOps methods. How? No more system engineers, no more build and release engineers in this project. No more system engineers and no more build and release engineers. Process remains the same, but here build and release engineers tasks and system engineers tasks are done by DevOps engineers. Code to be converted to an artifact done by DevOps engineer. Configure the platforms with the required dependency software. That task is also done by DevOps engineers. So DevOps, as we know, the first part represents development and ops part represents operations, right? DevOps, two different words. We need some development activities, some knowledge into development, as well as some knowledge into operations too. Correct? So now, what sort of development knowledge is required? Means when developers write some code and upload into GitHub, as DevOps engineers, we should have some knowledge, like to convert the code to an application. Which tool should we use here? Should we go with a MS Build tool or Maven or Gradle or Ant? Based on the technology which is used by developers, we have to develop an artifact. So what sort of tool we have to use? We should have some understanding. In which programming language developers are writing code, we should have some understanding. We should have an understanding about the build scripts. That sort of knowledge is required for DevOps engineers. There's nothing like, you have to know object-oriented programming, C language, C++, Java. No, you don't need to have that level of extended knowledge, but some sort of development knowledge is required for DevOps engineers. Okay, mostly our activities, our focus will be on operations. We perform a lot of operations like configuring servers. Production environment, let's say Sinopec Banking LLC, they have hundreds of servers where we have to deploy this product or deliver this product. How to deliver this software to or deploy it into hundreds of servers. And on all those hundreds of servers, how to pre-configure all those environments. That sort of knowledge we should acquire. Okay, and as DevOps engineers, how we automate this entire process means we use a tool called Jenkins over here. This square box here, this rectangle here. Think of it as a Jenkins server. Okay, we use a tool called Jenkins. This Jenkins server, what it does is we configure Jenkins server in such a way that whenever developer uploads some code into this version controlling tool, developer need not to update us. We configure Jenkins in such a way when there is a code in the version controlling tool, immediately download it. And we configure this Jenkins server with some tools like Maven and Gradle, okay, some build tools. And we pre-configure our Jenkins server that the downloaded code should get converted to an application. We does that task too. Deploy the artifact. Once the artifact is created, deploy it into QA. even we automate that step. Okay, and just here, if we try to perform some automated tests. If the automated test cases are failed, Jenkins server, we configure it to update all the teams involved in this project, saying the test failed on this project. Okay, and if test failed, a report is sent to development team, and development team again they rework and upload their code into version controlling tool. Now what happens again? Jenkins identifies if there is a code change. It identifies that, downloads the code, and converts an artifact. Again, the artifact is deployed into QA test team. Okay, any of these steps are failing, Jenkins, in Jenkins we have this notification system using which we update the entire team. We try to update the entire team about whatever the changes are happening, whatever the issues are getting raised in this project. So this way, if QA is finalized with the approval of some release manager, we deliver product to the client. Even that task Jenkins does. Okay, so and one more thing, if we want to configure our servers with some kind of configurations, we got a tool called Ansible. There's a tool called Ansible. Using this tool, we can make configuration management on hundreds of servers. Now let's say to deploy this artifact at the production level, there are hundreds of servers. On all those hundreds of servers, I have to install Java and I have to deploy this artifact. As a system developer, as a systems administrator, the task is quite hectic. Deploying an artifact, configuring all the servers, it's a quite hectic task. But what we do is we use this tool called Ansible. This Ansible tool, what it does, it targets one server or 100 servers at a time, and it does all the configuration management in one go. Installing Java, how much time it takes on a single server, the same amount of time on hundreds of servers. As you know, like if we talk about big data, in big data, the logic is transferred rather than the logic is transferred to the servers, and logic is implemented at server level, and request is collected at the source level, and we get a response back at the source server. Similarly, Ansible, whatever the command we write, the command is transferred to all the servers, and on all the servers, the command is implemented at the same time. So we have this tool called Ansible to speed up the process of deployments. Okay, and one more challenge in this in this agile model, why releases are getting delayed, and what is the downside for agile model means. One task we discussed so far is coordination issues between the teams. Coordination issues are affecting this releases and ensuring quality. Okay, releases are getting affected in agile because of coordination issues. We addressed that by removing build and release engineer team and the system engineers team, and we as DevOps engineers kicked in and we automated this entire process. And what is the other factor which is affecting agile means environment issues. Environment issues means the artifact is generated here. This artifact is developed by the code is written by developers, and developers, let's say, they have written some particular version of Java. In order to run this artifact, Java version 8 is only required. Java version 8 is the only required software to run this artifact. The dependencies in Java version 8 are only suitable to run this artifact, let's say. But we did not realize that we installed, let's say, on QA environment, Java version 9. Now, the application might behave properly or might not behave properly. We cannot guarantee that. Or let's say at the production level, we installed Java version 11. But developers are pretty clear that the artifact runs only on Java version 8. But at the QA level, there is another version of Java. At production level, there is another version of Java. So now what happens? QA team, they route back to the development team saying there is a problem with the application. And developers, even they test their application. But since they install Java version 8, for them, the application works absolutely fine. For development team, the application works absolutely fine. Why? Because they have proper set of dependencies. They have proper set of dependencies. But QA team, they don't have enough or proper set of dependencies. So the application might behave a bit weird. So over here, the QA team, they're not back to the development team saying there is a problem with the application. Whereas development team, what they do, they respond back to QA saying the application is working absolutely fine at our end, because they have deployed the application in a correct set of correct requirement. QA level, the dependencies are somewhat different, dependency mismatches, so the application might not work properly. QA says it's not working on my machine, development team says it's working absolutely fine. Now, what is the problem here? Whose mistake is this? Means we cannot say it is the mistake of a developer or it's the mistake of QA. Both of them are correct in their perspectives. QA team, since Java version 9 is configured, the application is not working properly because of dependency mismatches. Development team, since they know that this particular version of Java is required, they are they are correct in their perspective. So to avoid this, this leads to a problem called IWOMM. Meaning, development team says it works on my machine. QA team says it's not working on my machine. So to address this issue, what we do is we Dockerize applications. With the concept of containerization, what we try to do is we Dockerize our application, meaning the application is converted as a Docker image. Okay, along with the application and its dependencies, we package the application together. This application requires Java version 8. We add an application and the dependency softwares too, and we try to package them together as a single unit. Now, this Dockerized application, irrespective of the platform, wherever you create as a container, it behaves the same. It behaves the same. Why? Because when you Dockerize an application, this is your application, and the application requires Java version 8. Okay, Java version 8. You are combining both of them as a Docker image. Okay, and this image, if you create a container out of this image on Windows platform or Mac OS or CentOS or some other Ubuntu flavor, different flavors of different operating system types. Now you create a container out of this image. What happens is the container has an application and its dependency softwares within the container. This is the application, and the application has its dependency software too. So there is no question of the application misbehaving or the application behaving a bit weird on different platforms. The same container is created on all the platforms, meaning the application is carrying its dependencies too. Maybe on these different platforms, let's say this is Windows, and on this Windows machine you already installed Java version 11. But the scope of this application, it won't go outside this container. It has its dependencies already pre-packaged in this container itself. So the application reaches out to Java 8 within the container. Maybe on Mac OS Java version 11 or Java version 13 is installed. Not a problem. Your application within the container, okay, it reaches out to the dependencies within the container. So there is no question of IWOMM problem here. Why? Because your application behaves the same irrespective of the platform, irrespective of the dependencies, whatever might get configured on other servers. Right? So with this Dockerized concept, what we do, since there is no question of IWOMM problem, definitely software releases do happen at a rapid pace. Whatever developers have written, the same thing gets reflected in QA environment. So since developers, perspective is getting displayed at QA level, there is much more ability to find the issues faster and get them addressed soon. Yeah, friends. So this is how agile model we discussed it so far, and these are the principles, or these are the methodologies which we include in agile and speed up the process of software development to software delivery. We fulfill the motive of agile by implementing DevOps principles, addressing the issues like coordination issues, environment issues. Okay. Now, if we read the definition, now it makes sense to you. A set of practices that combines software development and IT operations. IT operations here, why IT operations? We have to configure the servers too in DevOps. Okay, no system engineers. We have to configure the servers according to the requirements. It aims to shorten the software development cycle, provides continuous delivery with high software quality. Yeah, once sprint 1 is done, developers switch to sprint 2, and the process keeps on going continuously. DevOps is a complementary with agile development. Several DevOps aspects came from agile methodology. Okay, so DevOps principles, whatever are we implement, are to speed up the process of agile, and we use these different tools. Developers upload code into GitHub, so we should have an understanding on GitHub. And there is a tool called Jenkins, using which we automate the entire process of software development to software delivery, deploying artifacts into QA, creating an artifact, releasing the application to production. All these stages we configure with a tool called Jenkins. There's a tool called Maven, using which we create artifacts if it is a Java-based project. Okay, but the scope of this course, we will discuss about Maven only. Maven as a build tool, we identify different stages involved in Maven: validate, compile, test, package, verify, install, and deploy. All the stages of Maven we discuss. And friends, there are a lot of DevOps tools. There is not only a Jenkins tool for performing CI/CD activities. We got Bamboo, we got Circle CI, Travis CI. But if we get an entire idea, or we get an outline by learning one tool, mastering the other tools is not that difficult. So maybe at your organization level, they might be using the version controlling tool, which is SVN, Apache Subversion. Not a problem. If we learn Git, the idea and the picture remains the same. There might be some slight differences. That is it. Okay. So if we learn Maven, mastering other build tools, it's not that difficult. Docker for containers, creating containers and creating images, Dockerized images. Kubernetes, a tool for container orchestration, where we get a lot of things into much more some more additional concepts. Like, let's say if I'm creating an application, I want to make my application highly available. I created an e-commerce website, and I want to make that e-commerce website highly available. But the application I deployed into an application server, it is capable of serving only 200 user requests. Whereas the input to my website is around some 1,000 or 1,500 users visiting my website. So how to scale up my container and make my website accessible to everyone? Okay. In case of any failure, how to handle those issues? These sort of things, we deal with a tool called Kubernetes, a container orchestration tool. Scaling up servers, scaling up resources, scaling down resources, these sort of activities, and handling failover scenarios, load balancing, all operational related activities. I don't want to scare you right away discussing all those, but there is a tool, Kubernetes, using which we perform all these activities. Ansible, a tool. From one single machine, we configure hundreds of servers. Okay, if I want to install Java on hundreds of machines, from one machine, I write a command, and that gets hit on all the servers at a time. And with a single command, all the servers are configured in one go. Not only installing something, creating users, deleting users, all Linux related activities, administration activities, we can perform on hundreds of servers from one single point of control. Okay, AWS, to implement all these, we need multiple servers. To create multiple servers, definitely we need a platform to perform activities. Locally on our laptops or on our local machines, if we have to set up our architecture, definitely we should have decent amount of hardware resources. Your laptop should at least have 16 GB of RAM or 32 GB of RAM, right? So since we don't have that high-end configurations, we try to rely on AWS services, creating servers in the cloud, okay, utilizing some AWS resources which are necessary for our DevOps operations. We learn AWS. Terraform, Terraform for automating AWS services. We write some scripts, we maintain some scripts, and we try to automate services in AWS using a tool called Terraform. Next, Python Docker automation. Okay, to perform some there is a concept called Docker Swarm, something similar to Kubernetes, but Docker has some limitations, like auto scaling is not possible with Docker. So that is where we learn a tool called Python Docker. Python implementing automation with Python in Docker concepts. That we will learn. That also we will cover in this course. Okay, and the main prerequisite for this course is Linux concepts. If you are getting started with DevOps, or if you are getting started with cloud, any cloud, the basic prerequisite to get started into cloud environment or to into into DevOps, Linux concepts and some networking concepts are the prerequisites. So last but not least, we learn Linux concepts in detail. Our discussion, once we get started with our DevOps course, first we begin our discussion with Linux concepts. We learn Linux, okay, and then we will get into Git. Okay, and few more tools I forgot to add in this slide. Like we will discuss about SonarQube to validate the code written by developers. We use a tool called Nexson to create our to preserve our artifacts. Okay, we learn, instead of Nagios, we learn a tool called Prometheus for monitoring servers. Since we work on multiple servers in a distributed environment, we have to track down whether our servers are in active state or not. Are there any issues? Whether the resources are available or resources are getting exhausted. We have to monitor servers too. So for monitoring servers and even monitoring services in servers, we use a tool called Prometheus. Okay, and finally, Jira, an issue tracking tool, how the projects are assigned and how to track down the project status. We finally, towards the end of the course, we discuss about this Jira, an issue tracking tool. Okay, so these are all the tools which are available and which are going to be the discussions for us throughout our DevOps course. Now, yeah, Linux administration and shell scripting, Git version controlling. Now, some of the questions which were raised by the previous, raised by some of the participants in the previous session. People are concerned about coding in DevOps, because many of them, they try to switch from non-IT to IT background. Their main concern is there a lot of coding involved in DevOps? The answer is no, friends. But scripting knowledge is required. To automate few things, scripting is required. Let's take this example. Let's say I'm assigned with a task that I have to run 10 Linux commands whenever once I log in. After 2 hours, again I have to run those 10 Linux commands and monitor my servers. Again, after 2 hours, I have to run the same set of commands and monitor my server status. This way, friends, I have to run some set of commands on a regular basis, let's say. To type the commands all the time, every 2 hours to type the same set of commands, it's a tedious task. We can simplify that by writing a script, okay, creating a cron job, so that the server itself hits that script file and executes them. As DevOps engineers, we are involved into multiple tasks, right? Not just since we are DevOps engineers, we are performing the activities of build and release engineers and system engineers. We have a lot of things to do. So to speed up our process, we need some scripting knowledge, and even learning the scripting, not way too scripting knowledge is required. Some extent is sufficient for us to automate things. It's not coding. Scripting knowledge is required. Anyways, we teach shell scripting and Python scripting in this course. Okay, next. Yeah, for setting up our platform, we can rely on AWS Cloud, and from day one itself, we get introduced to AWS Cloud. How to create resources in AWS? I will walk you through all those concepts. Okay, virtualization is a concept using which we can set up our lab environment on our local machines, but it is not at all recommended or suggested. Why? When we want to create multiple servers, definitely our physical machines gets heavily affected. So we don't go with virtualization concept. We go with the concept of connecting servers, creating servers in the cloud and connecting at the cloud level. Okay, so Any questions, friends, so far from the discussion today? Any questions? Oh, I did not realize time. It's 10.
Yes, hi Prasanth.
Yeah, hi Nagesh.
In this session, we are not covering Jenkins.
In this session?
Sorry, in this training
Yeah, definitely. Why not? See,
period.
after Git, we learn a tool called Jenkins.
Okay, Jenkins. Yeah, I
Yeah.
thought it is okay. Okay.
Yeah, it is Jenkins. Yeah. So,
Okay.
some more tools I did not add here. We will cover some other tools too, like Tomcat as an application server. Next, we cover we go with Sonar Cube, Nexus, okay, and New Relic. There are, but some tools are way too limited. Some of these tools here we have extended discussion, like Git. It lasts for a week. Jenkins, around 10 sessions we discuss Jenkins concepts. Docker around 10 to 12 sessions. Kubernetes 15 sessions. Ansible for 2 weeks we have discussions. Okay, some tools like Nagios 2 or 3 sessions sufficient. Maven 1 single session is sufficient. Okay, Terraform 3 or 4 sessions. We don't go deeper into Terraform. Okay, but to understand the workflow, which tools play a major role, those tools we discuss in detail.
Then what about the AWS tools?
Sorry, AWS?
Then what about the AWS tool? How many sessions we will discuss?
AWS around 10 sessions we cover, like around 15 sessions, 15 services in AWS we try to cover.
Sorry, 15 sessions.
Yeah. Excuse me, friends, just give me a second. Oh, sorry, friends. Yeah. So around 10 sessions, we discuss the AWS concepts.
Okay.
We will cover solutions architect course in this AWS discussions. But, I will provide you with some recorded sessions on AWS. Like this DevOps course, completing all these tools only takes us 2 months of time. And again, covering everything in AWS in live classes, it becomes extremely difficult. So what we do is, once we are done with the first month of discussion, from the second month, you get some recorded sessions on AWS added to your drive, like 45-minute discussion or 1 hour discussion. We add them, and that way you gain exposure to AWS too. If you have any questions, we address those questions in the class again. How to create mostly, we try to learn how to create servers, Linux servers in AWS. But at interview level, they might ask you questions like how to create a Windows server. Those sort of things, we provide you with some recorded sessions, self-learn recorded sessions, where you do practice. And if you face any issues, you'll get back to us and we will address them. But the idea here is to provide you with a complete overview around the tools which are in demand. Kubernetes, not just showing you with how to install Kubernetes. We do a deeper dive into Kubernetes, different services in Kubernetes, creating pods, services, replica sets, replication controllers, okay, horizontal pod autoscaler, and Helm charts in Kubernetes. All these we will discuss in detail, because at interview level, okay, when you are adding experience, based on the experience, you will get questions from these different tools. If you are going with 5 years of experience as a DevOps engineer, the focus will be mostly, the questions you get are mostly from Kubernetes, Ansible, Docker, okay, Terraform. So what are the major areas where developers, where interviewers put their focus? We cover all those concepts, because the idea here is to make you job ready, okay? And the struggle what we face for the next 2 months, we have to get something out of this struggle. You investing time and money, you should get fruitful out of this. And me as a trainer, whatever I deliver, I should get satisfied once you get a job. So that is the idea here, friends. Okay.
Thank you. Actually, I do have one more question.
Yes.
It's about during the course.
Mhm.
Are you guys gonna walk us through the live projects as well?
Towards the end of the course, we have,
Okay.
first things first, we will discuss every tool and options available in each and every tool. Okay. Once we are done with getting, exposure at every tool level, towards the end, we connect the dots. Like we do a project, whatever the code is available in Git, using Jenkins, we pull the code, perform CI/CD, and we try to perform operational activities with Kubernetes, Docker, and all these. That is towards the end, connecting the dots. All that happens towards the end of our course. Yeah.
Sounds good. Thank you.
Yeah. So, any other questions, friends?
How many days is the classes will be continue?
Sorry, what is that, Sridhar?
How many days will the classes will continue?
The class is that is what it's a 2-month course.
2 months course.
Yeah.
Total 60 classes around, right?
Yes, 60 sessions, definitely. More than 60 you'll get included with the recorded sessions. Yeah.
And Monday to Friday or Monday to Saturday, Sunday?
Monday through Friday. Saturday or Sunday we take a break. But it's a 6-day. We spent 6 days.
Okay.
Yeah. So friends, if you are willing to get this recorded session and the slide which I discussed, just drop me your mail IDs so that, drop me your mail ID or your mobile number so that, we will, for further communication of correspondence, our team will get back to you. Okay. Any other questions you have, you can reach out to the management too.
Sorry, I joined late. What's your name? Forgot.
Yeah, my name is Prasanth.
Prasanth.
Mudassar. Yeah.
Nice meeting you.
Yes. Sure, Mudassar. What I'll do is I'll provide you with the recorded session, whatever session we recorded today. We'll provide you on your email. Okay.
Thank you.
Yeah.
Thank you very much.
Thank you.
All right. Bye.
You can reach out to the management. They will update you, Syed. Okay. Okay, friends. Thank you. Thank you very much for your time. I'll see you the next time. Good day.
Thank you.